Welcome back. This is second video of our chapter reversible reactions. In this video, we will be talking about different factors which affect equilibrium. Once the reaction has achieved equilibrium, now the concentration of reactants and product will remain constant. It will not change. But we need more product. So how we can break this situation? How we can shift the equilibrium toward reactant side or product side? So there are three factors. Number one, pressure, temperature and concentration. By changing these conditions, we can shift equilibrium towards right or left side. So how pressure affects equilibrium? By increasing pressure, the reaction shifts toward less number of moles. Okay. For example, in this example, you can see you have nitrogen plus hydrogen, it makes ammonia. So on the left side you have 4 moles of gases. Remember, pressure is only affecting the gas moles. Okay, solid and liquid are not considered in this discussion. Pressure only affects the gas. So in this example, there is 1 nitrogen, 3 hydrogen, so 4 moles on left side and 2 moles on your right side. So when you increase pressure on this reaction, the reaction will shift toward less number of moles, mean toward product side in this case. But in this example, uh, you can see 3 iron plus 4 H2O, it makes Fe3O4 and 4 H2. In this case, there is no effect of pressure in this reaction. Why there is no reaction, no effect? Because on both the side the number of moles of gas are same. On left side you have 4 mole of gas and on the right side you have 4 moles of gas. So there will be no effect of pressure in this case. So when there are same number of moles of gas on both the sides, in that case reaction will not shift. Okay. The second factor which affect equilibrium is temperature. By increasing temperature, the reaction shifts toward endothermic side and vice versa. For example, in this case, you can see N2 plus 3H2, it makes 2 ammonia and it says exothermic reaction. As you can see that delta H is given minus. Okay. Examiner will give you information about the reaction is exo or endo. But you remember that when delta H is negative, it is exothermic. And when delta H is written positive, it is endothermic reaction. So this is exothermic reaction. Mean its forward side is exothermic and its back side is endothermic. So when you increase the temperature on this, reaction will shift on endothermic side, means back side, left side in this case. Okay. And if the reaction is endothermic, means the forward side is endothermic, then by changing temperature, the reaction will shift on right side, forward side. Okay. Third factor which affects the equilibrium is concentration. By removing something or by adding something, the reaction shifts accordingly. Reaction shifts toward the lesser quantity. Okay, reaction shifts toward lesser quantity. Means if you add something on reactant side, the reaction will shift on the product side, and if you add something on product side, the reaction will shift on reactant side. Similarly, if you remove something from the product side get less. To fulfill that gap, the reaction will shift to the product side. Okay, hope you got this. Do like, share, and subscribe us.